For this question, we want to determine the greatest area that can be fenced in for a given amount of money using two different types of fence. Well, we can see that the total cost is going to be $20 times one length of fence plus $15 times a width plus 20 times the length plus 15 times the width, because the north and south wall are both at $20 a meter and the east and west walls are both at $15 a meter. So collecting like terms, we get 10,000 equals 40L plus 30W. What we want to do next is isolate for L, and we see that we end up with L equaling 250 minus 0.75W. Well, at this point then we know that the area is going to be length times width, and since length is equal to 250 minus 0.75W, what we have there is an expression in terms of only one variable. So we can say area as a function of W is equal to 250W minus 0.75W squared. Now, keep in mind that because we know that we only have $10,000 to spend, we know that we can either use all $10,000 on lengthwise fence, meaning that W could be 0, or we could spend all $10,000 on widthwise fence, meaning that the width would be 1,000 over 3, because 30W would equal 10,000. And those are the endpoints of our domain, so that the extreme possible values for W are 0 and 1,000 over 3. Well, what we're going to do now, so we need to find our domain, which we've done, and now we are going to take the derivative of the area function with respect to W, set that equal to 0, and we'll see that W is equal to 500 over 3. So now, in using our algorithm, we need to use the two endpoint values possible for the width, as well as the value for W that set the derivative equal to 0. And we're going to see which of these three options gives us the greatest area possible. It turns out that when the width is 500 over 3, we get the greatest possible area of 62,500 over 3 meters squared, or in other words, about 20,833 meters squared.